All right, hey there, everybody, welcome back. We got a little bit more to do in 17.3 today, a little bit more on circles. So what are we doing? We're doing math, like a 17.3 part B, more on circles and radians. We talked about radians as a reminder. There were pi radians in 180 degrees. So we were doing a lot of conversions. We did some practice converting back and forth between radians and degrees. And like, why do we want to do radians when we grew up learning degrees the whole fucking time? Because when we look at circles, if I have a circle like this, and I got some section right here. Let's pretend that's curved. This little segment right here is called an arc. And the arc length, which we call S, I don't know why we call it S, there's no S in arc or length, is equal to R times theta, where theta is this angle right here. But theta has to be in degrees or in radians, because radians are unitless. And so, like, if R is in inches, let's say R is in inches, S needs to be in inches also. We want to have the same, if we're talking about a measurement of length, we want to have the same thing. And since S equals R theta, the only way R times theta stays as inches is if there's no units, and 180 degrees has units, it has degrees. But when we switch away from that, we get to radians, we're good. So let's take a look at some examples there. And the little piece I carved out right here, that little area right there, this is called a sector. And the area of a sector also uses theta in radians. The area of that little wedge right there is 1/2 R squared theta. One second. And I can show you something. We're going to be doing the area of the segment in a little bit too. Maybe I'll wait and show it to you then. Why we don't use degrees. Let's just look at an example. If the angle is let's find S. If R is 20 centimeters and that central angle theta is pi over 3 radians. So S equals R times theta, which equals 20 centimeters times pi over 3 radians, which is 20 pi over 3. And let me figure out what that measurement is on a calculator real quick. 20 times pi divided by 3 is approximately 20.944. It's also in centimeters. And if it helps you any, half a circle is pi. So if you're trying to picture how big something is, like pi over 3 means it's going to be only like this would be pi over 3, pi over 3, pi over 3. So you can get an idea of how big of a slice of pie that is. Let's do another one. Let's find theta if the arc length is 7.5 meters on a circle radius 5 meters.
So what are we looking for?
We're looking for theta, which is the angle. So we have S equals our theta. Arc length is S, that's my S. So I have 7.5 equals 5 times theta. So if I divide both sides by 5, I get theta equals, what is that, 3/2? 1.5? If you reduce it.
What was it divided by?
Because I'm trying to get theta by itself. And if I divide it by the, we did this a little bit in algebra. If you divide by, pretend this is x. And we had 5x, we would divide by 5 to get rid of the 5 in front of it. You remember doing that? Kind of like if we had 2x equals 4, and we wanted to find out what x is, we would divide by the 2. We're doing the same thing here. I've got 5 theta equals 7.5. Theta is just another variable. We don't know what it is. It's like x. So we'll do the same thing here.
So if I want to follow the formula, it will be the R is 7.5.
R is 5,
Um,
and S is
Yeah.
the arc length is 7.5. So I'm just plugging those in right here. I plug the 7.5 in here,
Oh, okay,
and I plug the R in there.
I see where, I was not reading the problem.
It's all
We're
good.
looking for data, so we have to change stuff.
Want to make sure that you understood. Don't want you
Sorry.
walking away not knowing. Ask questions. Don't be sorry. Ask questions when you have.
And 1.5 will be meters.
No, actually, the 7.5 had meters. The 5 had meters, and so when I divide both sides by meters, the meters actually cancel out. There are no units on this
Oh, yes.
because it's radians. Good question. Ready for more? Okay, so we also looked at, draw this again. You know what? No, not. I'm gonna put it on the screen using this. I'm gonna draw it because I need to scan it. I want to scan it. So. If we had something like that. We said a line that goes through where it hits 2 points, it's called a chord. Are you gonna start?
Yeah.
And this part here is called a segment. And the overall shape is called a sector. This whole thing, the area of this whole thing is the sector. So. Let's say we had a circle here. With a radius of 6 centimeters. And let's say the angle there is 30 degrees. We can find the area of the overall sector. The area of the sector is 1/2 r squared theta. But theta again has to be in radians. So if theta is not in radians, we have to convert it to radians. We can do this here by multiplying by whatever unit we have, we got to get rid of it. So I'm going to put degrees on bottom, and the relationship between pi or radians and degrees was pi over 180. So I'm going to multiply by pi over 180. And 30 over 180 is actually just 1 over 6. So this reduces to pi over 6.
So one of them,
I took the 30 degrees and I multiplied by pi over 180. And 180 is the same thing as 30 times 6. So I crossed off the 30s. And I'm left with just pi on top and 6 on bottom. So pi over 6 is the angle right there. We want to find the area of the sector, we gotta do 1/2 r squared theta, and we had r in the picture shows is 6 centimeters. So I'm gonna do 6 centimeters squared times pi over 6. This is 1/2 times 6 times 6 times pi over 6. That's 6 squared. And a centimeter squared gives a centimeter squared at the end. The reason why I'm showing you like this, you could throw it into a calculator. There's a lot of steps right here throwing it into a calculator. If I just take a little time and cancel stuff out, 1/6 cancels out there. 1/2 times 6 is 3. This just ends up being 3 times pi centimeters squared. Now that's not really a helpful number, but at that point, putting in 3 times pi in a calculator goes real quick. And that is 9.42 centimeters squared. You have your phone out, Ariana? What is that? Oh, okay. It's like a phone, sorry, my bad. Flip it over. Got my eye on you, girl. All right. So that was finding the area of the sector. The way you can find the area of the segment, if you really need this segment right here, and sometimes you do, like there's shit in industry and stuff like that, where you like kind of want to shave off that segment. The area of a segment is, what we can do is we can take the whole sector. We'll take the area of the sector. And we just want that wedge right there. That's all we want. So what we're going to do is we're going to cut out the triangle. Which means if we're going to take away the triangle, we got to subtract the area of the triangle. Which means you need a little bit more information from the picture of what I had up there to do this. If we had something like this, and this was 6 centimeters, and this was, we said, pi over 6 degrees. We need information about this triangle. Let's say that the height going like that, that's my height, even though it's weird. Let me, if I rotate it like that, it's a little easier to see his height. Let's say the height there is 9.3. And that makes this part right here my base. And my base is going to be, I have that backwards. Base is 9.3. The height is going to be 4.24 centimeters. So if I rotate this picture and make it look more like a triangle. That is 4.24. And this length right here is 9.3. We already found the area of the sector. So if we're doing the area of the sector, well, another piece of paper. I'm going to rewrite it down. It was about 9.42 centimeters squared. The area of the triangle we have to calculate. But if you remember from our equations, that is 1/2 base times height. So in this problem, that is 1/2 times 9.3 times 4.24. And this is centimeters and centimeters, so we end up with centimeters squared. And I don't know what this calculation is, I gotta do it. $19.716. Why is the area? Something's off here. I did something wrong somewhere.
Yeah.
Yeah,
You can give me one freebie.
no. Your freebie was not having to take the test a week ago with everybody else. Something's off, because we're gonna end up with a negative area. What's off? Did I just pick numbers that don't work? Is that what I did? I must have. Yeah, I think I put together two different fucking pictures. Maybe I did. Maybe those numbers don't go together. Let me check again. Ah, yeah. All right, let's try this again. So, the idea of the area of the sector is correct. The idea of the area of a segment is correct. Scratch the shit. So let's find the area of a segment. Where the angle is 90 degrees. That's what's wrong. I had the wrong angle listed. We still have radius is 6 centimeters. That height is 4.24 centimeters. And that chord length is 9.3 centimeters. So the problem is my picture was bad. That's 4.24. This is 9.3. That's 6 inches. And that angle right there is 90 degrees. So we want to find the area of the segment And the area of the segment. I'll draw a little picture like that. Area segment equals the area of the sector minus the area of the triangle. So the area of the sector is 1/2 r squared theta. I have theta as 90 degrees. And I don't want it in 90 degrees because I can't use degrees. So I need to multiply this by pi over 180 to get rid of the degrees. So if I do that here, 180 is 90 times 2. So the 90s cancel out. And I get, and just write it out, 1/2 times 6 times another 6, because it's 6 squared, times 1/2 pi. Because all of this right there turns into pi over 2. 1/2 6 is 3, and 6 times 1/2 is another 3. This one ends up being 9 pi. Which is approximately 28.27 centimeters squared. You were way the fuck back there. Don't you even fucking shake your head at my gas. I will come sit back there. I'll bring a fucking tablet so I can sit right next to you and telegraph my stuff over Zoom to the screen. That way, anytime I just gotta hike a leg for you, you'll get it. All right, so that was the sector. Now we need to find the triangle. You're way, but 1/2 base times height. We just did this one. This is the one I want to describe. This ends up being centimeters squared also. And when you throw that in a calculator, that is 19.72. So the area of the sector is the 28.27 minus the 19.72 centimeters squared. I don't know what that is. $8.55. One last thing before we finish this up. We were saying the area of a sector is 1/2 r squared theta, where theta is in radians. In degrees, the area of a sector equals theta over 360 r squared pi. How's that for shit you want to remember? It's not too bad if you think of it like this. Theta over 360 times pi r squared. Because that's the area of the circle. And so here you're just doing what proportion of the circle. But do I have this equation memorized? No. I have that one memorized because there's just 1/2 in there. That's a hell of a lot easier. All right, you guys ready for 17.4? Volumes and surface areas of shapes. Fucking thing is tripping out. Stop tripping out. I just fucking broke it. Not shapes, volumes, and surface areas. Three-dimensional shapes. I just pissed it off. So I'm going to show you a picture on the computer, and then I'm going to try to draw it. When we say right rectangular, right circular, or right something like that, there's going to be a right angle. A right angle is 90 degrees. So this is just a box. And this is basically just a soup can. Okay. When they are oblique, they're kind of like skewed a little bit. Like if it was a homeless person's box and it was leaning against fucking something, and it was like not. Why did I make it a homeless person's box? That was fucking not right. That's fucked up. All right, so we have right shapes, which include our box. We could have our soup can, which is a little bit less easy to draw. And this is called a rectangular prism. And this is called a circular cylinder. I don't know any other cylinder shapes. So that's confusing to me. Cylinders are always circles. And so like in this picture, like that's my height. And same thing right here, that's my height. And if I wanted to look at it like this, I could call this right there my base. That's the base of my box. And that's the base of my cylinder. When we do oblique shapes, it's kind of skewed, so I'm going to over exaggerate the skew here. This is still my base. That's still my base. But the height is now this. Not the length of the side, but the actual vertical height. And we don't have to have square and cylinder bases. I could have a triangular shape. Yeah, if you come show it to me first.
I'm gonna do one now.
Okay, just rip it out and hold it up for me. Just rip it out and hold it up for me to show me that it's black. And this one, again, the height is the distance here. But base is going to be the bottom of the triangle. And these are oblique prisms. Yep. Yeah, your graph paper has holes in it. Aren't we fucking fancy? I'll have to show you my graph paper that I have in my office. This is just a pad. There's no fucking binder holes.
Oh, yeah.
So the volume of any of these shapes. Volume equals the area of the base times the height. So we tend to use like a little b for like base where it's a side. I'm going to use big B, capital B, to mention it like when we're doing the bases area. So V equals B times H.
Small p is value.
Small b is like when we have a triangle. We call that the base and this the height. So B is a side, that's a little b. That's how I'm distinguishing between capital B is going to be the area of the like it's going to be these red things in these pictures. That doesn't say area very well, does it? There we go. Red shaded areas above. Let's just do a couple examples real quick. Everyone go with this page? So let's do, we're gonna have a cylinder with a 15-inch diameter and a 24-inch height. And we want to find the volume. This is a big motherfucking soup can. It's 2 feet tall and over a foot wide. This is a big fucking can. So my height is 24 inches. My diameter, which is all the way across the circle, is 15 inches. The volume is the base times the height. For a circle, for a cylinder, the base is a circle. We're looking at for the area of a circle right here, times the height, because that's my base. The area of a circle is pi r squared. So r here is not 15. What is the radius? What's the relationship between the radius and the diameter? Anybody know? It's half of it. The radius is 1/2 the diameter, yes. So 1/2 of 15 inches is 7.5 inches. So we'll use that right there. My height is 24 inches. And I got a pi out front. So I've got pi times 7.5 squared times 24. I am getting 4,241.15. Let's see if I do that. How many is that? There's a pi. This is 1,350 pi. So you get 4,241.15. I have inches squared times inches gives me inches cubed. So you can write inches cubed like that, or you can say cubic inches.
I think I understand that. 1,350, how did you? by
That's just the
multiplying?
numbers multiplied.
Oh, okay.
7.5 squared times 24.
Okay, then you have.
Yeah, multiple, verify that in your calculator. Make sure you get 1,350. Ignore the pi for now. Just do 7.5 times 7.5 times 24. Ooh, that one had a little bite on it. It's too bad I'm not sitting next to Ariana. I would get grossed out on that one.
Yeah. You know what? Me. I agree, but you on the other hand. Forcing.
Oh, wait.
Oh, no.
Oh, damn, like, get your way back.
Oh, look at this, look.
Oh,
Mm.
Hey, you took it at you.
That's what you get for imagining it's horse semen. You sick fuck. Were you in here that day? I don't know, you were in here that day. Where are you, Bertha?
No, she wasn't.
Oh, you missed that day. Oh, were you?
Yeah.
That was a good day. Did you get 1350 when you do?
Yes.
Okay, so let's look at another one.
Why did we get inch square inches? I mean, not square inches, cube.
So right here, you gotta look up. If you're not looking at the screen, I can't point to it.
Okay.
So I've got the inches squared and I've got inches. So I've got inches squared is really inches times inches. That's those two. And then that inches gives me another one. And so when you have anything times itself 3 times, you get cubed. That is a universal thing. This is worth noting. This is very, very, very important. Area comes in square units. Volume is always in cubic units. Always, always, always. Let's do a triangular prism. We will have let me rephrase that, a prism with a triangular base. The height of the prism is 15. And the triangle looks like this. Right there. I don't know what that value is. Second. .6 is the height. And those are also in centimeters. So it's kind of like we have this like this. And this is 15 long.
Oh, that's what I was gonna ask.
And this is 3, 3, and 3. And that's 2.6.
So it's gonna be like lowercase h.
Yeah, it's a lowercase h. And the base is 3. So we're going to do big B times big H. And big B is the area of the triangle, which is 1/2 little b times little h times big H. So I have 1/2 times 3 times 2.6 times 15. And each of these had a centimeter that I didn't write down, and I wish I had. .5. And that is centimeters cubed. I gotta tell you, I was making these lecture notes earlier today, and there was something I learned today that I didn't know. In regards to volumes of shapes, I know a lot of shapes and volumes and equations and shape. just worked with him in math for so long, but I didn't know the following information. I need to show you the pictures first. So, because I'm gonna fuck up the sketch. The cone I won't fuck up. I can do a cone. So we got a cone here, you know, it's like a snow cone upside down. It's got a flat base. We've got pyramids where you could have a triangle base, you could have a square base, you could have any kind of base as long as the sides are all the same length. This is like a pentagon base. So, and the sides of these are called the lateral faces. And they use altitude for pyramid rather than height. I don't know why. Same thing. But what I didn't know is that the volume of any of them is 1/3 BH. That's what I'm gonna put back over here. I knew the cone was 1/3 times the base times the height. But I didn't know that was true for fucking pyramids too. So it didn't matter what the shape of the base was, as long as it's like a cone shape in some form. I think it's pretty cool. So volumes of cones and pyramids. And this distance here is the height. Let's see if I can do a good pyramid. It'd be easier if I draw the vertical height up first and then draw points leading to that didn't fucking turn out very well. I need to rotate it more. That might make it show up better. So in each of these, the red picture is the height. Big B is still the same, it's the base. Base area is big B. And for each different type of cone or pyramid, it's got a different area. Area of a circle is different than the area of a triangle, and different than the area of a square. We could have like a pyramid with a rectangular base, so it's all kind of different. But no matter what the shapes of these, the volume is 1/3 big B times H. Let me use capital H here again. That's really neat. So let's just do an example. We have a pyramid. We have a pyramid with height of 32 centimeters. And a square base with side length of 20 centimeters. Find the bottom. You know what? Why don't we make this 33 centimeters? I'm gonna make that 33 centimeters. So the bottom of the pyramid is a square. I got 20 centimeters by 20 centimeters. we want the area of that base, the area of a square. Is S squared. So. 20 centimeters times 20 centimeters will give me the base. The base is 400 centimeters squared. Which is going to put my volume one-third times 400 centimeters squared times 33 centimeters. The 33 and the one-third, these two combined, they multiply together to make 11. So I've got 400 times 11 centimeters cubed, which is 4,400 cubic centimeters. And if you put it in a calculator, you should get that, unless I'm doing something wrong. You guys ready for more? Let me give you guys one to try. Let's do a pyramid with a triangle base. And the triangle base looks like this. It's 9 centimeters on the side. And H right there. H is 7.8 centimeters. And we're going to do the height of the pyramid is 28 centimeters. Let's do 28 centimeters. Find the volume. What?
How do we get the area of the triangle?
The area of a triangle is 1/2 base times height. Little base times little height.
You know why the area sounded different, the formula for the area sounded different to me.
There's two ways to do the volume or the area of a triangle.
I went to school in Mexico, so the way they taught it is base pretty much the same.
Base times height over two.
Or 10.
All right, so we went through this. I'm gonna write it. We've got 1/3 big base times big height. Which is 1/3 times 1/2 times base time, little base times little height times big H. So I'm just gonna plug all this crap in. Just divide your answer by 3. My little base is 9 centimeters. My little height is 7.8 centimeters. And my big height is 28 centimeters. And when I multiply that all together, I get 327.6 cubic centimeters.
So how can we do it like step by step?
Yes,
Or
if I just wanted to find the triangle first. The triangle is 1/2 the 9 times the 7.8. And that's my big B, right? So 9 times 7.8 divided by 2. This is 35.1. And this will be centimeters squared because it's an area. So my volume will be 1/3 35.1 and 28 centimeters cubed. Is that how you wanted it? I'm going to show you the next one. I will try to sketch it. It's going to be a train wreck. I guarantee it's going to be a train wreck. But it's worth knowing. I'm not going to test you on this one because the fucking formula is horrendous. Check this bitch out. The frustum of a cone. Thank you. Or this is the same thing as a pyramid too. So you have like a snow cone with the base down, and you make a cut through the cone that's like parallel to the base. So like the cone has, let's see if I can do this any justice. There is a circle on top. And it kind of comes down like that. There is a circle on bottom. And let's see, this is like the cutoff cone from above. It's cut off the top. So that piece has got the frustum.
UFO or what?
What?
UFO?
Kind of, right? It looks a little like the UFO, you're right. So I got a little circle on top. And I got a big circle on bottom. And like, if maybe I could, since we have circles, I've got R1 and R2. My height is gonna be the distance from the top of the cone to the, or the top to the bottom, which would be that right there. That would be the height. And they call this length right here S, which stands for slant height. Which kind of comes into play when we do surface area. We haven't gotten to that yet. We're getting that next. So. And this holds true with like, it could be a pyramid base. So it could be a pyramid base. And obviously we wouldn't have a circle anymore. So what I'm going to say is instead of doing that, let's just call this top one. Let's call the top B1 and the bottom one B2. So base one area, B1 is top area. And B2 is bottom area. So the volume of a frustum. For a cone or pyramid. Equals 1/3 times the height. You call that big H right there. Times B1 plus B2 plus the square root of B1 times B2. Frustum. I assume I'm saying that right. So let's do a cone one.
I miss you.
An hour and a half worth of shit. Hour and 10 minutes worth of shit.
So that formula is for both?
Yeah, just like
Okay.
the volume for the entire cone was the same for either one. The volume for the frustum works for either one, just the bases are different. Like the base for a pyramid and the base for a cone. One was circular and one square. It's the same idea. There's a different formula for each B though. This is why I said I'm not testing you on this one. That's why I said I'm not testing you on this one. But in case you need it for your career, we're gonna go over, like, do a problem, and there's probably 1 or 2 on the homework. So let's just look at the volume of cone frustum. And we are gonna have for the top circle a radius of 5 centimeters. Okay, let's say feet. I'm tired of using centimeters. And the bottom circle will have a radius of 8 feet. And the height will be 5 feet.
You know, there's a sorority that's called theta.
Yes,
So that's why when I say theta,
it's usually not just theta, it's usually like 3 Greek letters. Sororities and fraternities are like Phi Theta Lambda, Lambda Lambda Lambda, Theta Theta Theta, Tri Delta. They are based on, they go with 3 Greek letters. Theta is like a Greek letter.
have some weak ass parties.
Depends on where we're going. It's a long ways away. Quit distracting me. Let's get to the shit. All right, so base 1. We want the area of a circle with radius 5 feet. So for both circles, the base is going to be AR squared. Because that's the area of a circle. So, not AR. Fuck am I saying? Pi r squared. AR squared. It's you're fucking distracting me. So, for the top circle, we have pi times 5 feet squared. It's gonna be 25 pi square feet.
Wait, just real quick. Do you remember the AR reading though?
What the what?
The AR reading, it's called AR reading.
I don't know what that is.
It's like
What does AR stand for?
To be honest,
Accelerated reading.
The solver.
where's I got it?
I don't know that she was an accelerated reading.
They are meant to.
Burn! No, you might have. You probably were. That's why you wear glasses. You read too much as a kid.
Yeah, I was a hella bookworm,
That's it. Nailed it.
but then life changed me.
Yeah, that's what you are. That's what comes to mind when I look at you is fucking 100% thuggy. All right, base 2, we have an 8-foot radius. And that's gonna give me 64 pi feet squared.
The streets out here are ruthless.
I'm trying to avoid shifting to decimals until the end. The streets out here are ruthless, yeah. We have crime in the valley, we do.
Yeah, especially these like.
I just saw a dead body not that long ago.
What the fuck?
What is that?
Yeah,
It was out on the cuts where on the side.
what side of what?
It was like literally right next to the tech prep and the ag.
Huh.
And but I didn't know if he was dead, but then I didn't see any blood.
So she saw a sleeping homeless guy, is what she saw.
No, I
The ag thing over the like the COS ag or the. What are you talking about? Where's the tech?
Okay, tech prep is like if you're heading towards the west side
Uh,
on Barsley. So
okay,
if you keep going straight on Barsley
okay.
and
I know where it is. Yeah, okay.
so literally it's the ag, it's not called the ag center, it's
Oh
like the
God, she
FFA
lives near me.
area, you know? And then the tech prep and then that dead body.
Or sleeping person.
Oh, yeah.
All right, you're done. You've had your few minutes of distraction. So the volume is 1/3 the height. The height was 5 feet.
Trying to say something.
Then B1 was 25 pi. B2 is 64 pi. And I got B1 times B2 is 25 pi times 64 pi, and then we take the square root. Which should be 40 pi. This is brings out a 5 pi, and that brings out an 8 square root of pi. Yeah, that's a 40. So this whole part is 40 pi. So V equals 5/3 times, I've got 25 plus 64 plus 40 is 129 pi. I don't know what all that is. This is gonna be feet cubed. If you just skipped all that and put it straight in your calculator, you get to the same spot.
How's it cube? Everything is squared. Or,
The bases are squared. When you add in the height, it adds another feet to it. 5 times 129 times pi. Divided by 3. I am getting. I hope this is what you guys are getting. 675.44 cubic feet.
When you multiply by pi, how many decimals do you have?
I stopped with 2 when I was done. I just did all the calculations, then I ended with 2. You kind of want to not round until the end. Like if you're doing little subparts, write down a few more decimal places than you plan on rounding to at the end. You don't need to write down 8 decimals if you're gonna round to 2, but if you write down like 3 or 4 decimals, when you finally get everything done, then round to whatever decimal place you want to round. That's why I did it this way, so I avoid your rounding anywhere along the way. Yeah. I don't know if you guys know this, but May is Teacher Appreciation Month. Now, you guys don't need to show me any appreciation. I know you guys appreciate me. But if you have other teachers like your people in ag, your horse teachers, I hear they like gift cards to GameStop. Or Starbucks, something else. Here's that pyramid frustum. That was funny. We're not doing it. I did one, one frustum was enough. All right, so one more volume we gotta talk about, and then we're gonna talk about surface areas.
Sorry, that just came up.
We are missing one shape that is probably the more common shape than you use over anything else. What is the 3-dimensional shape that we have not covered? We did that, that's a rectangle. That's a box.
Sphere.
Oh, a sphere, yeah.
Who said that?
Fucking the magic box that we have.
Say your name.
Sphere.
And you fucking suck.
I think it was David.
Oh, what's your name, David?
Yes,
Did they show up at all?
yes, David shows up. David usually sits back there.
Oh, he was the one that wanted the charger, I think.
Insert fucking random useless fact here. Compliments of Ariana. So the volume of a sphere is 4/3 pi r cubed. How big a ball, how cross do you think an earth ball is? Those big things they let kids play with in auditoriums that are fucking way bigger than the kid, like maybe 3 feet across. They're fucking big old balls, they fucking. They're called earth balls. Never, you didn't do that?
No.
Not you either, you don't?
I didn't realize they're called earth balls. I think it's something.
They're just fucking they're gigantic balls that they, like, you can't, they're taller than a kid, they're like 6 feet, no, they're not 6 feet tall, there's no way they're 6 feet tall. But I'm gonna pretend they're
Still inside.
Let's find the volume of a sphere. Of radius 3 feet.
You know, that's like.
I think it's called an earth ball.
Jones.
But
It's that object, it's where the earth is, but then, it's small. You know, it can go on someone's desk type of thing, you know, for like science.
a globe,
Oh, you're talking about, I didn't know, it's your spinning ball. I thought you were talking about.
I don't know what she's doing.
Your feet are on something, you say, there it is.
Know what it was?
Like the one where you see the planet, all the continents and everything, yeah, it's a globe.
Okay, yeah, cause they'll like spin it and be like, what is this thing?
Yes, that's a globe. That's geography. Get your geography shit out of my class. So the volume is 4/3 times pi times 3 cubed. 3 feet cubed. So this is 4/3 times pi times 3 times 3 times 3.
Is cube or cube the same thing?
Cubed. What do you mean? Cubed is like, no, they're different. If you have a D on the end, they're different. So like one of these threes will cancel out. Check that out. And I got 4 times 9. This is 36 pi cubic feet. I don't know how much that is. Let's figure it out. It's gotta be a little over 100.
What if you don't cancel the green, you just go along with the whole?
You should, if you go along with the whole, you should get this value.
Say that one.
No. Because if you get this answer, that's correct. I try to avoid doing as many things in the calculator as I can when I can cancel shit out easily. Because I make more mistakes doing this.
I know, but sometimes it just.
Right, so, but yeah, I'm showing it both ways. You can go straight to calculator. All right. We're not gonna do it for time constraints, but you might get a problem like this in the homework, and I want you to know how to do it. So what if they say, find the volume of this? And they've got something that looks like a cube or a cone on top. And then there's a cylinder base. And then there's a half a sphere on bottom. And the height of the cone is 8 inches. And the height of the cylinder is 10 inches. And this is, let's say this is 12 inches across. And they want you to find the volume. So what I have here is I have a cone on top of a cylinder on top of a half of a sphere or hemisphere is a half a sphere. That's a cylinder. And that's a cone. They tell me it's 12 inches across, which means if I made little circles right here and found the radius.
Hemisphere, is that like half of the sphere?
Yeah, hemisphere is half of the sphere. The radius has got to be 1/2 that 12 inches. So 6 inches. Half of the sphere. You've probably heard the word hemisphere before, but didn't ever think about it. The northern hemisphere and the southern hemisphere, below the Earth equator and above the equator. You had to have had some sort of fucking in geography somewhere. So when you're going through it, the volume of the cone, when you figure, remember the cone is 1/3 BH. The cylinder is BH. Hemisphere, we're going to do half the volume of a sphere. Because it's half of the sphere. Does that make sense? Bertha, are you with me?
Yeah.
Okay, so the volume of the cone. The base of the cone is a circle. So the base of the cone is pi r squared. And then we got big H.
Big H for,
No, big H is where it is that one. Say H1, H2. When you do the cylinder, the base of the cylinder is a circle. The area of a circle is pi r squared. Just like we had up here, same thing as the base of the cone. And that one's going to be times H2. And then when you do 1/2 the volume of the sphere, we've got 1/2, and then the sphere was 4/3 pi r cubed. So if you have something like this, you would add them all up. The total volume is all of them. All right. So let's talk about the other part that's in this chapter, surface area. Like when we have a cylinder or a box or something like that, we call the surface area of the sides is called the lateral surface area. And our book, and thus probably our homework, abbreviates that LSA. And for all of our prisms and cylinders, cylinders, it equals the perimeter of the base times the height. So pH. Then the total surface area jackasses in the book decided to call it TSA. Like that doesn't have another meaning. The airport shit. The total surface area is the lateral surface area plus the top and bottom areas.
well,
What?
the mean?
What's the what?
The mean,
Total surface area.
TSA is total surface area.
other,
For the airport. Something security airport agency, transportation security agency. Bam. Damn, I bet that's it. So this is going to be different for all of them. But for rectangular things, the bottom is just, we call B, right? And the top is just B. So total surface area for these prisms and cylinders is pH plus 2B. Because that's B and that's B. We call that B. We call the bottom B. And these sides are the lateral sides.
And it says the area of the narrow, that word, something area, is that all the sides?
It's all four sides. There is another way of doing it if you don't like this formula. You can find the area of each side and add it up. So let's look at a cube, or a rectangle. Let's do a rectangle, a box, a rectangular box. So let's say the box is like this, and let's say the bottom is a square shape. Maybe it's 3 feet by 3 feet. But the height is 5 feet. I don't know, like a refrigerator box. So what are we gonna have here for the total surface area? We're gonna have 4 sides. And then 2 tops, basically, because the top and the bottom are the same. Right? So what's the side here? The way of doing it without the formula is going, okay, we've got 4 sides of the box, right? You're good with that? So each side is, this is 5 and this is 3. So one side is 5 foot by 3 feet. So that's 15 square feet.
That's the area.
That's just one side. And the top or bottom is 3 feet by 3 feet. So 9 square feet. That's just one of them. Now there are 4 sides, so I need to do 4 sides plus the top plus the bottom is 4 times 15 plus 9 plus 9, which is 78 square feet. You can do them one at a time if it helps. The cube, the box like this is easier to picture than a cylinder. If we do the formula for TSA was pH plus 2B. So the bottom is 3 feet on a side. So it's 3 feet all the way around. P is 12 feet. It's P. The height of the box is given 5 feet. The base, I've got 2 times B is 3 by 3 is 9. So 2 times 9. So I've got 12 times 5 is 60, plus 2 times 9 is 18. And again, I get the 78 square feet. To be honest, do it this way. I go, what is the area of each side? And I know there's 4 of them, and I add it up. If you want to do the formula the book's going to use, and if you do like walk me through it, like click on ask for help or whatever, it's going to probably do this shit. But you can go through and go, okay, this is a box. If I unraveled it, it's going to have 4 things like that, and then it's got a top and it's got a bottom. If you opened up a box and laid it flat, it would look like that. Or I guess you could probably, you would probably see it more like that. This is like laid flat. Like if you open, you know, like literally cut the damn thing up. You can do the same thing when you picture cylinder if it helps you. If you don't want to do the cylinder formula as it is. If we unwrap that, like picture, like having a label around the cup and you peel off the label and you're laying the label flat. We're gonna have, it's gonna make it like a rectangle because it's flat. But the bottom of the rectangle is going around the circumference of the circle. Does that make sense? The bottom of the rectangle is around the circumference of the circle if I peeled off a label. So this is the circumference. And we still have the height of the cylinder. And then you also have the top circle and the bottom circle. So you'll have to do the areas of all of those to find the surface area. Or you can use the formula. Let's do look at doing a cylinder. Cylinder is, let's say, we did a cylinder. What's some cylinders earlier? What kind of cylinder would we use? Okay, I'll just make one up. Let's say a soup can is what, like maybe 2 inches. Soup can, maybe a 2-inch radius. I'm guessing. Do not go home and measure this shit and go, no, that's not it, Mr. Jones. I will tell you to kiss my ass. Soup can is 2-inch radius, maybe 4 inches tall. Now, I'm going to do it the formula way first. The formula for the total surface area is the perimeter times the height plus 2 times the base. Perimeter of the circle is 2 pi r. The area of a circle on the bottom, the base, is pi r squared. So I put all this shit in. I have 2 pi times the radius, which is 2 inches, times the height, which is 4 inches. Plus 2 times the base. The base is pi, and the radius is 2 inches squared. And we'll walk through doing the other format right here, where you, if you unwrap a circle, or unwrap a cylinder. What do I have here? I've got 2 times 2 is 4. Times another 4 is 16. I've got 16 pi on that one. And here I've got 2 times 2 is 8. I've got 8 pi on that one for a total of 24 pi inches squared. And I don't know how much that is. It's about 75. If I could wrote a 3 here. 75.4 square inches. I think using this formula is easier for most people to do than trying to picture unwrapping the label on a fucking soup can. Because it does end up making a rectangle like I showed up here. But most people don't picture that and can't relate the circumference to being the bottom of the rectangle. They can do the height pretty easy. If they can even get that it's a rectangle. Like if you actually had it on it and you peeled it off, you could lay it out flat and you totally see this. In fact, going around the cylinder. And when I take it off the cylinder, it turns into a rectangle. Now, if I had cut into it, you could see that the bottom of the this rectangle right here is actually the circumference of this circle. But let's do it the other way. If you like doing it this way, we got to do this. We got to find this one. So the sides, other way. The lateral sides is a rectangle that has circumference on the bottom and height right there. So circumference is 2 pi r. And they gave us r was 2 inches. So this is 2 pi times 2 inches. Or 4 pi inches for the circumference. The height was given as 4 inches. So this thing ends up being c times h, the area of a rectangle there. 4 pi inches times 4 inches is 16 inches. Then we got to do the top and the bottom. Both of them are a circle of radius 2. So top and bottom are the same. Let's just say 16 pi. Top and bottom are the same. It's pi r squared. So pi times 2 inches squared. Each of these are going to give us 4 pi. And if you add up 16 pi for the rectangle, and 4 pi for the top and 4 pi for the bottom, you get 24 pi. Like I had right here. That doesn't look very good. Let me rewrite that. Before I turned it to a decimal. You want to do the surface area of a sphere? Surface area of a sphere has a nice simple formula. The total surface area is 4 pi r squared. So it's like the area of a circle times 4. It's crazy. So what was the circle we did a little while ago? We had a 3 foot earth ball. I said was 3 feet. Did I say 3 feet or did I do 2 feet? I did 3 feet. So the surface area of the earth ball. Our 3 foot earth ball. 4 pi times 3 feet squared is 36 pi feet, square feet.
Do you have a glass?
No. Holy shit, that ended up happening miraculously. The same as the volume in this one, but that's only because the radius was 3. This ends up being 113.097 square feet. There is a 1 per a cone. Here we go. I will give you the information. I'll go through if no one started chapter 17 homework. I bet you've started chapter 17 homework yet, haven't you? So I can't go and delete it.
I don't know if I worked on it or just clicked on it.
If you clicked on it, it's fucking makes it so it won't let me delete. If you've only clicked on it and not started it, no one started chapter 17. I will delete that you started it and I will get rid of the fucking what I'm about to show you right now.
You're saying don't start it?
If you haven't started it. I don't know. Let me check. I'll know right away.
Isn't it due on the 17th, right?
Let's see if anyone started chapter 17.
I answer and.
David's got 30% done. You're all doing it. I'm not gonna give you, it won't be on the test, of course, because I don't like this thing. But if you want the surface area of a cone,
It's 6 footballs.
it is. The lateral surface area is pi RS, where S is the slant height. R, of course, is that. And the total surface area has to have that thing, the pi RS, plus the bottom. And the bottom is pi R squared. So that is the total surface area of a cone. A pyramid, I can't give you a general formula for because it depends on how many sides the bottom has, and they are fucking clusterfuck equations. You're not gonna have them whip up all that. But it does the same thing. You could try to break it up and go, yeah, I gotta measure the side area of each side of the pyramid and then add the base. So if you didn't do a formula thing, you could work it out. All right, get the fuck out. 6 o'clock.
I don't
See ya.